Index law number 3, also called the power to or power law. When raising a power to another power, we multiply the powers or multiply the indices. So for example, 4 to the power of 3, and notice that we've got brackets around it, to the power of 2 is equal to 4 to the power of 6. So that's 3 times 2, okay? So being multiplied to give you 6. So how come? All right, why is this so? The first thing we do, we're going to expand the brackets. Okay, so 4 cubed, or 4 to the power of 3, all squared. That really means that whatever's in the brackets is repeated twice. So we're going to write it as 4 to the power of 3 times 4 to the power of 3. And we know from index law number 1 that when you multiply two terms with the same base, you add the indices together. Okay, but if you're not convinced, 4 to the power of 3 is 4 times 4 times 4, multiplied by another 4 to the power of 3, which is 4 times 4 times 4. How many do we have? 1, 2, 3, 4, 5, 6. 4 to the power of 6. Let's have a look at some examples. Now, at any time, you can pause the video, have a go at the examples for yourself if you'd like to give it a go, unpause the video, check your solution against the work solution in the video. First one, 2 cubed to the power of 4. Now, you don't have to use a calculator necessarily, just use this index law, multiply the indices when they're raised, when one index is raised to another. So 2 cubed to the power of 4, that's 2 to the power of 3 times 4, which is 2 to the power of 12. A cubed to the power of 6, that's just a to the power of 3 times 6, a to the power of 18. Xy to the power of 3. Now, when you have two pronumerals, you basically split them up, okay? And the 3 is applied to both of those, both of the pronumerals, okay? So that's going to be x to the 3, or x cubed, y cubed. So notice that when you expand the brackets, it's a bit like normal expansion. The 3 comes down to each of the terms inside the bracket. Okay, moving on to some other examples. Okay, so if you like, again, you can pause the video and have a go at these questions. There's 4 there, there's 6 there. And unpause the video and then check your solution. So let's have a look at the first one. A squared, b cubed, all to the power of 4. We apply this index law number 3, the power to or power law, to each of these individually. So a squared to the power of 4, that's a to the 8. B cubed to the power of 4, that's b to the power of 12. Okay, let's have a look at E. 2xy cubed, all to the power of 5. Again, we do the same thing. The 2 is raised to the power of 5. X is raised to the power of 5. Y cubed is raised to the power of 5. And we multiply the indices. So 3 times 5 is 15. So that's equal to, now 2 to the power of 5, you can work that out on your calculator. That's going to be 32. X to the 5, y to the 15. Part F. Okay, this time now there's 4 terms. 3 to the power of 5. A squared to the power of 5. 2 times 5 is 10. B cubed to the power of 5. 3 times 5 is 15. C to the power of 4, all to the power of 5. That's C to the power of 20. Part G. Now, the fact that it's a fraction actually doesn't change anything at all. Again, you just deal with each of the terms individually. X to the 5 to the power of 3, that's x to the 15, over y squared to the power of 3, 2 times 3, y to the power of 6. Part H. Again, same thing. Okay, we're just applying the same rule over and over again. 3 to the power of 4, d squared to the power of 4, 2 times 4 is 8. Now, for the denominator, 4 to the power of 4, e cubed, all to the power of 4, that's e to the 12. Now we can simplify that. So 3 to the power of 4 is 81. D to the 8. And 4 to the power of 4 should be 256. Yep. E to the 12. And you can't simplify that fraction. So if you wanted to just check that, type it into your calculator and check to see that the calculator can't simplify that fraction any further. And the last one, part I, negative 2 x cubed to the power of 4. So that's a negative now. Negative 2 to the power of 4. We'll work out what happens there when you've got a negative. And then you've got x cubed to the power of 4. So that's x to the power of 12. 3 times 4 is 12. So let's see what happens here. There's a very interesting rule with indices that if the index is an even number, the negative becomes a positive. Okay, and there's a good reason for that actually. So if we put negative 2 in there in the calculator to the power of 4, you get positive 16. 16 x to the 12. So my question to you now is, why is this? How come negative 2 to the power of 4 is positive 16? Let's expand it. Negative 2 times negative 2 times negative 2 times negative 2. Okay. Let's do these in pairs. Negative 2 times negative 2 is positive 4. Negative times a negative gives you a positive. Negative 2 times negative 2 is also positive 4. 4 times 4 is equal to 16. And that's index law number 3.